Example 2, we take a look at the coefficients 4, -3. This one has 9, 12. And it's hard to tell because the order of the coefficients are not the same, but we can kind of get an indication that, 4 to 3, 12 to 9, probably about the same ratio. So I'm just going to rewrite this one here and move the x over. So I'm going to move the y over, and so we're going to make it negative. We'll make it 21 is equal to 12x minus 9y. And in looking at these coefficients n, we can see that they are in proportion to each other. So these are parallel lines. Okay, so again, the ratio of the coefficients on x and y, the ratio is the same. So I have, in one case, I have a 4 to 3 ratio, or so 4 to -3 ratio for equation 1. And for equation 2, I have a 12 to -9 ratio. This is the same ratio. Okay, so these are parallel lines. So what we can then do is we can take a look at the constant, and the constant is not in the same proportion. So this is a times by 3 proportion. Here, if we times it by 3, we don't get the same coefficient. Okay, so these are parallel lines, but they're not the same line, so they're likely to be infinite, or they were not infinite solutions, but zero solutions, parallel lines that don't cross. So let's take a look at what this solution looks like when we actually solve it. So I'm going to take equation 1, and I'm going to times it by 3, and so I'm going to end up with 30 is equal to 12x minus 9y. Subtract these when we solve it, we end up with -9 is equal to 0. Well, -9 is never equal to 0, so there's no solutions here. So this is what we call an inconsistent system, because this is not consistent. -9 can never equal 0. Okay, so this is inconsistent. There's no solutions here. So therefore, they must be parallel lines. So we can always go ahead and solve and see what our solutions look like, and we need to make sure we interpret our solution. So our solution here is -9 equals 0, not possible, so there's no solutions. Here we get something like 0 equals 0. Well, this is perfectly fine. We don't solve for any unique x. So because there's no unique x, 0 equals 0 for all x's, which means we have infinite solutions. So the other way we can solve this is we can just look at the coefficients and look that they are proportional. And if they're proportional, all the coefficients are proportional, then we know that we have infinite solutions. So that's example 1. In example 2, the coefficients are proportional, but the constant coefficient is not proportional. That means that we have parallel lines, but not the same line, so we have 0 solutions.